Hello students, let us go through lecture number 2 today. You may be remembering in lecture number 1 we have discussed what is basically the requirement of study of the strength of material. Why should we concern about the strength of material? How a material behave when some loading is subject, when load is coming on the members or any material, how material will behave. So that we have to understand the behavior of the material so that we can get the maximum benefit of the properties of the material. So that means we can decide where, which type of material we have to use, whether we have to use steel, RCC, concrete, or any type of building material. So today in lecture 2, now let us first of all understand some of the important definitions which we will be going through whenever we will study any topic in strength of material. Then these important definitions is very much required to understand effectively. Now, if you see here in this figure, there is a rectangular body. That means it may be any type of material. It may be of steel, it may be of concrete, RCC, or it may be of wood. And when some load is applied on it, load in terms of force is applied on it, then what will happen to this material? Suppose this is a rectangular bar, it may be a steel bar, and you are applying some force, and force may be tensile force, it may be compressive force, or any type of force. Then what will be the actual behavior of this material? Will it fail or will it not fail? So if you see here, then you will be able to see this one is the longer dimension, that is a longitudinal dimension. Now, whenever there is a rectangle or a cylindrical body, then one is the longitudinal dimension and other is, if you see here, that is the lateral dimension. So now we are more interested in studying that when a perpendicular force is applied on the body, that means a force which is normal to the surface is applied on the body. It may be a compressive force or it may be a tensile force. Then we have to understand the behavior of this rod or this bar, whether it will get compressed or whether it will get elongated or whether it will get cut, that means shear. So let us try to understand. Now, in the previous lecture, we have discussed when we are applying some force on a body, on a material, then due to that force, some stresses will be developed. And as you apply the force, the material, due to, due to its own properties, it will try to resist the external force. So, when your force is more than the resisting force, then there will be some deformation in the body. Deformation may be in terms of its length may increase, that means there may be some elongation, or if there is a compressive force, then there may be compression in the longitudinal dimension. So it is very much clear, if a material is such that when you are applying force, it can deform. Maybe after increasing the force, when you cross some limit, then it may deform. So let us understand what will be the deformation and how we will be discussing in this subject. That means what will be the our terminology and definition. So when there is elongation or compression, that means deformation in the body, then we will say some strain is getting developed. That means that material is strained. Material is strained. So, as per definition, that change in configuration. Now, configuration is a general word. It may be its length, or it may be its cross-section area, it may be lateral dimension. So, all will come under this one word, that is configuration. So, this is the standard definition. The change in configuration to the original configuration. Now, original configuration, suppose this member has some length L, and when you are trying to apply force, it will resist, and when you cross that resisting force, that means your applied force is more than resisting force, then this material may get some extension. That means its length may increase. So that means original configuration has been changed. So that change in configuration to the original configuration of a body, of a material, when some force is applied, so that ratio is known as strain. Mathematically, we will write strain is equal to the ratio of change in dimension to the original dimension, and the symbol we will be using for strain is epsilon. So this is a Greek word. This is the symbol for strain. Whenever you will be studying the strength of material, whatever be the topic, whenever you will come across strain, so you will be using this symbol epsilon. Now you can see here it is the ratio of dimension to dimension. That means it may be the ratio of change in length to original length. So strain is a unitless quantity. It don't have any units. So now what are the various type of stresses and strains which we have to study in strength of material? So let us type of stress on an element, that means body or an element, depends on the type of the load. That means what type of load is acting on it. Whether that load is a tensile load, then stress will be tensile stress. When there is compressive load, then stress will be compressive stress. Now, in general, we will be interested in normal force. If you see here, this force is making an angle of 90 degrees. So it's a normal force. Force acting at an angle of 90 degree to the cross-section area of the body. Now, if there is a tensile force, then tensile force means it has the tendency to elongate the body. Now here in this figure, this is a tensile force, that with this force is stretching the body outward. So that means if this force is able to elongate it, deform it, so then it has the tendency to increase the length of the member. So tensile force always has tendency to elongate. Then compressive force, yes, it is also a perpendicular or normal force. It will try to compress the body. So that force which has the tendency to compress the body, we will term it as compressive force. Third one is the tangential force. It's very important. The force acting parallel to the surface of body. Now, if the force is not a normal force, but it is acting on the surface, then it has tendency to deform the shape of the body. Here, deformation was related to its length, that means longitudinal dimension, but here deformation is to change the shape of the body. So body, shape of the body, that means body can get distorted or it can shear the body. Tangential force has two type of possibility. It can distort the shape of body or it can shear or cut the body. And if that force which can shear the body, so that force will be known as shear force, which is very important to understand what is shear force. Later on we will be going in detail. Now, tensile stress. As I have already told you, the type of stress depends on the type of the load or type of the force. Now, when tensile stress will act. Now, see here in this figure, this blue color body, that is the original size and shape of the body. Let us consider its longitudinal dimension is L, that means it may be L units. And when you are applying some force P, which is acting outward, that means it will try to elongate the body. So this type of force which is acting away from the body, that is tensile force. Now you can see, if this force is able to elongate it, then possibility that this body can get the shape which is shown as dotted. So you will observe here that there is decrease in the lateral dimension but increase in the length. Now the application of tensile force has tendency to increase the longitudinal dimension of the body and to decrease the cross section, or you can say lateral dimension. So when tensile force is acting on a body, then tensile stress and tensile strain can develop. Now let us formulate this tensile stress. So here in this figure, let us suppose L is the length of the member, A is the cross section area, that is the lateral surface area on which a normal force is acting. Suppose delta L is increase in length. This increase in length from both sides, if you add up, then let us suppose it is delta L. Delta L means very small increase in length. And obviously P is the tensile force. Then tensile stress symbol will be sigma is equal to P by A. So tensile stress is tensile force upon the area on which it is acting. So that is the lateral area. Now tensile or longitudinal strain. When we are talking about the tensile strain, that means there will be some elongation and definitely its longitudinal dimension will extend or elongate. So that's why you can say tensile strain or longitudinal strain. Again we are referring same figure. Now longitudinal strain or tensile strain, that it is epsilon T, T for tension, tensile, epsilon for strain. So it will be ratio of delta L by L. Now when we are talking about compressive stress, now same figure, if you see here in figure number 2, now force, external force is acting towards the body, on the body. So this is a compressive force, and compressive force has the tendency to compress the body. That blue color figure is original figure, and after application of force, let it deform, and you will be finding here that lateral dimension is increasing but longitudinal dimension is decreasing. So there may be some decrease in the longitudinal dimension or length. So the application of compressive force has the tendency to decrease the longitudinal dimension of the body and to increase the cross-sectional or lateral dimension. So when compressive force is acting, then it will be associated with compressive stress and compressive strain. Now if you find here delta L is decrease in length. Earlier in tensile stress, delta L was increase in length. So compressive stress is given by P by A, that is the compressive force divided by area cross section, and compressive strain, here you can use epsilon C, and we will be using here negative symbol that is delta L by L, or you can write it is equal to delta L by L, and within bracket you will write compression. So here there is decrease in the longitudinal dimension by original dimension. Then very important type of stress is shear stress. Shear itself indicate that shear means to cut something. Now if you see in this figure, there is a box or a body having some height h, and the red region shown is the surface area of the body. Now if you apply tangential force F, which is on the surface of the body, and suppose this lower face of the body is fixed, then this force will try to distort the shape of the body. Now here it was rectangle, now it is becoming trapezoidal. So shape of the body is changing. Now you will find original edge of the body has been shifted by some distance x. That is the deformation of the upper surface. Now force is acting on this surface. So this force has the tendency to distort or change the shape of the body, or it can shear it. Now here the terminology which we use, h is the height. Keep in mind h is the height or dimension of the member in a direction normal to the plane of application of force. Now here in this figure, plane of application of force is horizontal and we are taking vertical dimension. A is the surface area where force is applied. Now somewhere we can use it as delta L, or here we are showing as x. So delta L or x, that is the deformation. F, or you can write it as P also, it is the tangential or shear force. So shear stress is given by symbol tau, that is equal to F upon A, and similarly shear strain is given by symbol gamma, that is minus x or minus delta L by H, or you can take it just as a positive value of x by H. You can write it as positive x by H, that will be the shearing strain. Now whatever we have studied so far, that is we have studied force, and force will lead to stress, stress will lead to strain. So, and if there is a tensile force, there will be some elongation in the body. Now question arises here, if you are applying the force on a body, it is getting elongated, and how long will it elongate? You may observe, if you keep on increasing the force, then somewhere it will get break. So let us focus on this, how long it can bear the stress without any breakdown. So external force, that means stress you are applying, there will be some deformation, and as soon as you reduce the external force, let external force becomes zero, deformation will become zero. So it is very much clear that stress is applied and strain is getting developed. Now maximum limit of stress, here you are increasing the stress, there may be some limit for a particular material, so that maximum limit of stress, which on removal of stress, strain is also removed. So that means we are going to understand that what should be the maximum stress for a particular material. Suppose it may be steel, so how much stress you can increase, that means what will be the maximum limit of the stress up to which if you remove the stress, strain is removed. So that limit is known as elastic limit. So elastic limit is basically the maximum amount of stress which creates strain, but condition is that If the stress is 0, strain becomes 0. So this will be the property of the material. It depends upon the type of material and constituents of the material. So it will be different for steel, it will be different for other type of material. So what is elasticity, which is very important to understand? The property of a material by virtue of which it regains its original configuration after the removal of external or deforming force is called elasticity. So that means it is very much clear, if you apply zero force, there will be zero strain. If you increase force, there will be increase in strain. If you decrease force, strain will be decreased. But a material can behave like this, that when stress is removed, strain is removed. So if a material is behaving like this, it is showing the behavior like this, that on increasing stress, strain increases, and on decreasing stress, strain is decreasing. So we will say that this material is elastic material. And again I am repeating, the maximum stress up to which material behaves like this, that maximum stress is known as elastic limit. So it is very much, let us understand, when that material elastic is subjected to higher amount of stress, that means beyond the elastic limit, then after the removal of stress, the material will not regain its original configuration. So that means there will be some permanent deformation. Now after removal of the stress, strain will not become zero. Stress may become zero, strain will not become zero. There is permanent extension in the body. Such permanent extension in length is termed as permanent set or residual deformation. It means now deformation remains in the body. Residual means deformation remain in the body. So that is the permanent set. Here comes Hooke's law. Now from this behavior of the body, Hooke has developed one law. Hooke law states that when a material is loaded within elastic limit, not beyond elastic limit, so Hooke's law is valid within elastic limit, then stress is proportional to strain. So according to Hooke's law, if you increase stress, in proportion to stress, strain will increase. It means ratio of stress to strain is constant. And this constant is known as modulus of elasticity. So what is modulus of elasticity? Modulus of elasticity is the property of the body. So as the type of material you change, the value of modulus of elasticity will change. If the value of modulus of elasticity will change, that means a relation between stress and strain will change. So stress is directly proportional to strain. That is, stress upon strain is equal to some constant. That constant is known as modulus of elasticity. Again, we are focusing on term elasticity because this formula or this relation is valid within the elastic limit. Beyond elastic limit, this will not be valid. So go through all the details minutely and come up with your queries.